Hello, everyone, and welcome to our Microgrid Knowledge Quick Chat. I'm Rod Walton. I'm managing editor with Microgrid Knowledge and also EnergyTech.com. And both brands cover different aspects of the commercial and industrial customer side of the energy transition that is happening out there. And one of the biggest things happening now is this expansion on both the demand, distribution, and communication sides of the grid. Data center capacity growth with artificial intelligence, the exponential use and rise in renewable energy is perhaps at a crossroads. So, how can one help the other on the journey? And I've got the person who can really map it out today with Seán Adam, who is Vice President of Market Strategy and Innovation at AFL, which is a fiber optic provider and technology firm that's deeply engaged in energy infrastructure, broadband with data centers and other markets where communication systems are paramount. And let's be honest, that's all of them. That's all of the business sectors, right, Seán?
Absolutely, Ron, and greatly appreciate being here.
Great to have you and talk about the key challenges facing utilities and microgrid developers today, Seán. So right out of the gate, let's go to the first topic, which is what are the utilities facing now? What does it look like out there for them?
Sure. So, probably none of this is going to be surprising to the viewers of this, right? Because it's just become the thing that gets talked about almost every day, right? But I think overarching, the utilities are dealing with aging infrastructure. They've got a complex regulatory environment, cost of capital, tariffs. The latest tariff stuff has certainly not helped. And then you couple that all with accelerated load growth, right? After a long period of kind of load decline or flatness, that's turned around, right? So utilities really have to take on these challenges of addressing that load growth, and how do they actually align capacity with load growth? And so that's a key place, right, where microgrids come in, because you need to start to have that. You need to have the power where the load is, right? That's always with the problem today. There's a term that we often use, which is time to first kilowatt, right? How long does it actually take for that energy to get there? And that very much actually comes from our experience with the very large AI data centers, where they tend to think about time to first megawatt, right? They don't make any money till that server actually turns on, right? So for the utilities, how quickly can they get them that, right? But they're facing permitting and environmental studies, extended lead times on key components, right? Transformers are over a year.
Right, exactly. I mean, interconnection is a huge issue. But along those lines, how important is communication infrastructure in helping them master this brave new world that they're facing?
It's absolutely critical, right? Absolutely critical. The thing is, there's no one silver bullet that actually solves all those challenges, right? But a key quote that I once heard that I always keep in mind is, if you can't connect to a device or a location, you can't control it, right? And so that's really how we have to be thinking about this, right? So getting more out of the grid really requires utilities to actually have that real-time visibility into the state of the grid and the ability to really actually quickly act on it. So that not only actually requires communication infrastructure, but it actually requires one that's low latency, high bandwidth, highly reliable, and it has to be bidirectional. And so those are the absolute keys, right? And then they actually have to have the ability to integrate and analyze and act on that existing data.
I know, and on a macro level, that is the case, and really for everything. I mean, utilities and major interconnections are at the core of a lot of this. And a lot of what we deal with, though, Seán, is the distributed energy infrastructure, how the system is upgrading at the edge of the grid. You talk about visibility, and that is critical. I mean, it's a transformation that must happen, is happening, and it needs the right tools to really evolve into a bidirectional superhighway, correct?
Absolutely. So if you really think about kind of what's necessary at when you think about kind of that distributed energy and the energy at the edge, the primary requirement is grid stability. We have to start there, right? The number one thing that a utility wakes up every morning with is, how do I actually make sure my grid is reliable? And when the grid was unidirectional, right, where kind of generation was stable and a predictable firm power, stability was actually easy to maintain. But as soon as we actually start allowed kind of power to flow in back into the grid, right? Especially when a lot of that
Maybe the other
generation
way. Yeah.
of these intermittent sources are wind and solar and are intermittent, that becomes really, really hard to control. So for me, it comes back down to that enabling real-time data and analytics, right? Because without data, you can't act, right? You've got real-time sensing. It provides continuous data on the kind of the state of the microgrid and of the main grid. And it's really critical to actually optimize that performance. And so if you think about bidirectional power, it goes hand in hand with bidirectional communication, right? You need, we're creating a super highway of communication. It's because in essence, we're actually creating a whole lot of new on-ramps for power. So, and it's that ability to sense it and act on it. And what's really cool is that AI is actually one of those things that's going to truly help all of us come into its own.
So one of the things I like to hear about and new information on virtual power plants,
Yeah.
and using these kind of communication and control technologies to aggregate and move power from DERs into the utility grid and help it respond to things like peak demand crises. And there's other grid services as well that are important. And meanwhile, it also adds to the value proposition for utilities, microgrid developers, and their customers. I mean, it sounds like a case of win, 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 Seán. Is it? And can you elaborate on how you and AFL make that happen?
Sure, sure, sure. So, I think it's I think the when is now. I actually think virtual power plants is kind of one of the coolest things that kind of comes out of this evolution in microgrids and DERs, right? Because like you said, it starts to actually add that overall value, not only a value kind of monetarily, right, but a value of it truly starts to solve the power problem, right?
Absolutely. Yeah.
But it's a big challenge, you say, right? So, when I think about a microgrid, for me, I kind of think about it, look, it's a single point on the main grid, right? It can island itself, it can act independently. And you can kind of think about that as establishing this kind of like one-to-one relationship with the main grid, right? You manage the power flow, you share data. It's kind of like this conversation. You and I are chatting with each other. We might talk over each other once or twice, but on the whole, we kind of maintain our stability, right? All right, now let's actually think about a virtual power plant. That's actually a many to one relationship. It needs to look like one thing to the main grid, but it's actually made up of a whole lot of different things, right? That are
Absolutely.
being pulled from all the whether, and those could be microgrids, could be pulling together multiple microgrids. It could be pulling together DERs that are sitting on your property, right? And so, and these VPPs are supporting this kind of wider coverage area, right, with these multitude of generation resources. So it's that makes it so much more complicated because now instead of this kind of one-to-one conversation we're having, it's like actually you have a bunch of folks in the room and they're trying to talk over each other, right? And so for that, you actually need to coordinate it. So that's actually why you need a communication infrastructure and a very robust one, right? But AI is the ultimate coordinator because it actually is able to do it much faster, much more holistically than a human can, right? And so that's actually where the when is now because we're starting to have these technologies that are coming together that really are going to enable this.
Yeah. And I use this analogy where I think of like virtual power plants as the flip side of the microgrid. The microgrid is like this one entity on, close to the load that's serving that load. Virtual power plants are, as you noted, they could be tens, they could be 20s, 30s, even 100 or more DERs that are dispatching out into the grid. And there's a
Right.
lot there. So, I mean, I really wonder, what should the industries, both utilities and developers think about most when they're designing their communication infrastructure for tasks like that?
Absolutely. So the key thing that network operators, network and grid operators have to do is they actually have to think about designing for future needs and not just that challenge of today. So the investments that are being made today really actually have to be thought about in a generational way. And so fiber is actually the only future-proof medium that exists, right? And we are nowhere near the data transmission limit of fiber. So in 2021, the Japan's National Institute of Information and Communications, they actually transmitted data over 1,800 miles at 319 terabits. That's 319 million megabits. So
Incredible.
this is when I sit there and say fiber is future proof. We are nowhere near what that can support. And as you think about the, the grid, what we're building today has to be able to support us 5, 10, 20, 30 years from now, right? That's going to continue to evolve. And what the only thing you can be guaranteed is one, it will change, and two, it will need more data. So
Yeah.
the key thing that we tend to it's a term we've coined, we call it SAFER, SAFER. Sustainable, accessible, flexible, expandable, and reliable. When you're putting in a solution, you have to checkbox all of those, right? And that's really what they have to keep in mind when they're building a communication infrastructure.
The terabytes thing, I mean, that's mind blowing, but at the same time, that's the kind of terms you start to hear when you talk about the future with AI and data centers and all of that. So
Absolutely.
it's incredible that fiber optic is ready to meet that. Fiber is ready to meet that. And sort of building off of that, Seán, can you explain the importance of this term fiber through the grid? And while you're doing that, also maybe kind of talk about the role that 5G plays in the energy transformation.
Absolutely. Absolutely. So fiber actually provides true symmetrical gigabit communication, right? That's able to support broadband to homes and businesses, and it can be backhaul for private wireless networks and connectivity to in-network devices. And it's actually the only medium that actually provides symmetrical gigabit performance, right? So by symmetrical, it means that you actually can do the same speeds up and down. So again, remember we talked about the fact that not only do we need real-time sensing, but we need real-time control, right? This isn't like when we watch Netflix and we're okay with a really fast. We don't care if the upload's slow, right? You certainly care, right, when you're actually trying to do something that is truly bidirectional communication. So that kind of fiber deep network really kind of allows that to happen and establishes that backbone for both wireline and wireless connectivity. So, for me, I actually see fiber and 5G being partners, right? For the longest time, what I'll tell you is wireline providers like us in fiber and wireless providers that were doing 4G, we actually viewed each other as enemies, right? We were competing against each other. Then 5G came along. 5G doesn't work without fiber, right? So to achieve the real differentiated capabilities of 5G, which really are important for what we're talking about here is grid control, right? One of the key differentiators is what's called mass machine to machine communication, right? Because where we're actually evolving to is, where we've generally, like through our history, humans talk to humans, then humans talk to machines. Where we're evolving to is machines will talk to machines. These sensors will talk to other sensors, then AI will be in the middle of it, and we won't even be in the picture, right? And that actually means that you need this partnership between 5G and fiber to get there. And let's be honest, you can't actually connect fiber to every single device in the grid. It's not cost effective. Sometimes it's not even possible. And that means you need wireless, and that means you need 5G. And for utilities and independent power providers, that means you actually need private 5G. So
it is amazing as 5G bringing it kind of all together. The capabilities are there. I think we can sort of trust in that. And it sounds perfect for what data centers will need at this critical growth point, Seán. I mean, we've got to make AI and energy work together for good, right? And how hard is that?
Absolutely, 100% correct. And like I mentioned earlier, there's that really interesting intersection here because AI is a driver for the load growth, right? But at the same time, it's the potential solution for coordinating this seamless integration of microgrids and VPPs into the grid. And without having those microgrids and virtual power plants at the edge, we're not actually making the AI revolution happen. So, and then along with that is the communication infrastructure is absolutely paramount for data center providers. And a big thing that's happening today is what's called data center interconnect. that used to be just connecting like data centers on their own campus. But now actually what you're seeing is these AI data center clusters, they're attaching the clusters across hundreds of miles, or they're building out their metro rings. Because really what they're after, what they're trying to build is this like this neural pathway, right? The way to think about an AI data center is you've got a brain inside it, and now they're going to connect a whole bunch of brains, right? That connection is really what unlocks AI, and you need power sources at all of the individual nodes. And that's actually where microgrids and VPPs come in.
Yeah, and you've got a lot of smart people sort of envisioning this, seeing this coming together of these clusters. You've thought a lot about it. The Department of Energy's thought a lot about it, and I know you've paid attention to the DOE liftoff report around advanced grid technologies, the mission criticality and engagement and all of this. So, Seán, one last question around that. How do you describe what this advanced grid and its connected pathways will need to look like in, say, 5 to 10 years? I mean, how do we get there from here?
Sure. So the first starts with as we've chatted, right? It's got to be a fiber deep network that you're putting in, and one that's really providing that flexibility, extensibility, and future accessibility to support those future needs, right? Come back to our acronym SAFER. And it's a combined solution of fiber and wireless, right? Where it's really supporting this vast network of these interconnected devices, both sensors and actuators, and it's all orchestrated by AI. And as the demands for kind of communication increase, you got more data, you got more control. I truly see fiber needs to drive deeper and deeper into the distribution grid itself, and that's actually why we call that fiber through the grid.
Through the grid, right? It is a complexity that's amazing, but it feels like we're getting there. I mean, it's kind of like developing a neural pathway for the whole new way of deploying data, energy, and connectivity, all integrated. And who better to give insights on this than Seán Adam, who is Vice President for Market Strategy and Innovation at fiber optic provider AFL. Seán, thank you so much for your time and your future forward answers today.
Awesome. Thank you so much.
Yeah, glad to have you. And thanks to everybody who's joined us for this Microgrid Knowledge Quick Chat. For daily coverage of the commercial, industrial, and mission critical customer side of this energy transition, please check us out, microgridknowledge.com. And, remember that fiber optics, wiring, controls, communication, it all brings it together. And so that's where we need this. And thank you again for joining us. I'm Rod Walton, Managing Editor. Have a great day, everybody.